Good evening. We're going to work on graphing linear inequalities. Linear inequalities are similar to linear equation, but uses an inequality symbol. The solution. The solutions of inequalities are all the ordered pair that make the inequality true. So anything that's in the shaded area, or if it's a solid line, anything on that solid line. If it's a dashed line, those those points on the line do not are not solutions. So the solutions are on a solid line, but not on a dashed line. So let's go ahead and just jump into this. So first thing we're gonna do is put the inequality in slope-intercept form, just like we would do in standard form. If the inequality is in standard form, we're gonna put it in slope-intercept form. When we graph the line, we got here if it is less than or equal to or greater than or equal to, and basically we're looking at the little line underneath it. If there's a little line underneath it, we're going to use a solid line. If there isn't any line, in this case, there's no line under here, we're going to use a dotted or what I like to say dashed line. If it is greater than or greater than or equal to, we will shade above. If it's less than or less than or equal to, we shade below. So let's get into some problems here. So we're going to look at this example. So again, this is in standard form, so we need to put it in basic slope-intercept form with an inequality. So the first thing I want to do is subtract 2x from both sides. And what that leaves us with is negative 3y is less than negative 2x plus 15. Same thing, I'm going to divide everything by negative 3. Now what that leaves us is y. But remember, if we multiply or divide by a negative number, in this case we divided by negative 3, we need to change our inequality, so we're going to make it greater than. Negative 2 divided by negative 3 is just positive 2/3. X, 15 divided by negative 3 is negative 5. So we put it in slope-intercept form where negative 5 is my y-intercept and my slope is 2/3, positive 2/3. So let's go ahead and graph this real quick. So the first thing is we're going to negative 5. So we're going to go down 1, 2, 3, 4, 5, put a point. My slope says I go up 2, so I go up 1, go up 2, and I go to the right 1, 2, and 3, and put a point. Now, let's go ahead and do our line. When I look at my inequality, I notice that there's no line underneath it. So if there's no line underneath it, I have to make it a dash or dotted line. So I'm going to go boom. I'm making my line dash because I'm not going to make a bunch of little dots. So I made my line dashed. And now I'm going to look at the rest of the inequality here. And y is greater than. So the inequality is open towards the y, which means y is greater than, which means I shade above the line. So I'm going to shade above this line. Now let's talk about solution. We talked about solutions early on. So solutions, any point in the shaded area. So if I put a point here, well, that's -1, +1. That is a solution. If I put a point here, that's +1, +2. That's in the shaded area. It is a solution. Since I have a dashed line, this point on the line right here at +3, -3, since it's on the line is dashed, it is not a solution. This right here is not a solution. If I put a point right here outside the shaded area, that's not a solution. However, if I go to the origin and put a point on the origin, it's in the shaded area, that is a solution. I can go to -3, +5. That is a solution. So anything in that shaded area is a solution to the inequality. All right, let's move on to our next example. Let's go ahead and graph here. This is already in slope-intercept form, so I don't have to solve for y. All I have to do is identify my y-intercept, which is -5. So I'm going to go down 1, 2, 3, 4, 5, put a point. Then I'm going to identify my slope as +1/3, which means I go up 1, right, 1, 2, 3, put a point. I'll do it again. You go up 1, 1, 2, 3 to the right, and put another point. So what we have here is our line. Oh, before I move on, let's look at our inequality. Do I have a line underneath? No. So then when I make my line, it is going to be a dashed line. It's not going to be a solid line, dashed line. And then when I look at my inequality, the inequality is opened up to y. So y is greater than 1/3 x minus 5, which means I'm shading above the line, which I shade this direction. I'm shading here. Let's look at our next example here. Our next example we have here, we have y is less than or equal to negative 2x minus 1. Again, it's in slope-intercept form, so I just look at my y-intercept at -1. So I go to -1 and put a dot. I notice my slope is -2, but since I don't have a denominator, I'm going to put -2 over 1, which means I'm going to go down 2 and to the right 1. Down 1, 2 to the right 1. Down 1, 2 to the right 1. In this case, I do have a line underneath it. So that means that it's greater than or equal to, which means I have a solid line. And y is, since the open is not open towards it, it's actually open towards the -2x. What I mean by open, if you draw a little Pac-Man, he's eating the -2, not the y, which means that y is less than this, which means I shade below. Now, since this is a solid line, any point on this line, like if it's a point here, that is included in the solution as well as points inside the shaded area. Let's do this one right here. So it's the same process. I'm going to subtract x from both sides. What that leaves me is negative y is greater than or equal to negative x plus 8. Remember, I can't have a negative y, so I have to divide everything by -1. So what that leaves me is y. But remember, if I'm dividing by a negative number, I have to change my inequality. So y is less than or equal to negative divided by negative x minus 8. Where -8 is my y-intercept, so I go to -8. 1, 2, 3, 4, 5, 6, 7, 8. Put a point. And I know that since I don't have a coefficient, it is 1 over 1. So I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. And since I do have a line underneath, I know that it's a solid line. It's a solid line. And now, since it's less than, so it's less than or equal to, I shade below the line. Let's do another example. So here I have 3x plus 2y equals 0. So we're still doing the same process. We're going to subtract 3x from both sides. So what that leaves us is I have 2y is less than negative 3x, and I'm going to put the plus 0 for kicks for right now. Then I'm going to divide everything by 2. What that leaves me is y is less than negative 3/2 x. 0 divided by 2 is just 0. I don't have to write anything down. So with that being said, since I don't have a y-intercept back here, I start at 0. I started my origin right here. If you don't have a y-intercept, you start right here in the middle. My slope is -3 over 2, which means I'm going down 1, 2, 3, to the right 1, 2, put a point. Down 1, 2, 3, right 1, 2, and put a point. And since I do not have a line underneath it, it's not equal to, that means that it's a dashed line. And since y is less than, I shade below. All right, last two examples. I'm doing this because we really didn't talk about this when we did linear equations. So this says y is less than or equal to -4. So when I graph it, it's going to be very similar, not the same, but similar to y equals -4. So what I do when you have y equals, I go to my y-axis here, and I go to whatever number it is, which in this case, -4, go down 1, 2, 3, 4, and I put a dot. Now, if it's equal, you just draw a solid line anyway. But since it's less than or equal to, well, since we know it's equal to, that means it's a solid line, not dashed. And so we're going to draw a line straight across like so. And since it's less than, we're going to shade below this line. Last but not least, we're going to do x is greater than 7. Which again, this is very eerily similar to x is equal to 7. The only difference is we have an inequality, and that inequality is not greater than or equal to, it's just greater than, so it's a dashed line. So what we do is the same process. We're going to go to the x-axis, which is here. We're going to go over to 1, 2, 3, 4, 5, 6, 7, and put a dot. Now, if it was just x equals 7, I would draw a solid line going up and down. But since it's an inequality and x is greater, I'm going to draw a dashed line because it's not equal to. And I'm going to go up this way. So now, understand when you have an undefined slope, behind it is less than, in front of it is greater than. Again, behind it is less than, in front is greater than. It says x is greater than 7, so I want to shade in front of this line. As always, thanks for watching. Until next time.